Look, these are the examples. The determinant of A, here A is 4, 1, 4, 8, 3, 2, 4, 1, 2. That's the given matrix. The determinant of this A is what? You see 4, 8, 4, it has a common factor 4, because 4 times 1 is 4, 4 times 2 is 8, 4 times 1 is 4. The rest of them we didn't think about it at this moment. And then there is a common factor in the first column, so 4 can be out. Okay? Then you have 1, 2, 1, 1, 2, 1 left over in the first column. The rest of 2 columns are the same, so you keep it. Now you may consider 4 to 2. 2 is a common factor here. You know, 2 times 2 is 4. 2 times 1 is 2. 2 times 1 is 2. Common factor here is 2. So 2 can be out. 2 is out. Then left over are 2, 1, 1, 2, 1, 1. So here 2 times 4 gives us 8. Now, look. Previously, we have this property right here. Is one row 2 minus row 1, you have the same determinants. It applies here. Row 3, row 1 minus row 3. You see, row 1 was 1, 1, 2. So 1, 1, 2. Row 3 was 1, 1, 1. Row 2, we didn't do anything. We have a 2, 3, 1. 2, 3, 1. Using the property 3, row 1 minus row 3, the determinants are the same. That's the application. Okay? So, why do I need to do that? Because I know 1 minus 1 is 0. 1 minus 1 is 0. And then 2 minus 1 is 1. 2, 3, 3 are the same, so we copy it. 1, 1, 1 are the same, we copy it. Here is still 8. Now, look. This row, this element 0 is called A11 because it's on the first row, first column. This 0 is A12 because it's on the first row, second column. So it's denoted by A12. So is this case, first row, third column. So it's 1, 3. And then the determinant of this matrix can be expanded along the first row. And that's the definition. Okay? That should be what? A11, little case A11 times capital case A11. Little case A11 is this element. Capital case 111 is what? Is the cofactor. Okay? Yeah, cofactor, and then plus this element 0. Okay? Right here, A12 times the corresponding cofactor. Okay? Capital A12. And then is the last one. A13 times the cofactor, capital case A13. Yeah, little case A11 stands for the element. Here is 0, so here is 0. 1, 2, little case A was 0. Only the last one, A13, is 1. So you put 1 in front of it. Okay. Again, the cofactors are defined in this way. A11, you will have a negative 1 in front of it, and then 1 plus 1. You have a sign. And then A11 is what? A cross out row 1, cross out column 1, you have a 3, 1, 1, 1, 3, 1, 1, 1. So that's the A11. And then A12 is negative 1 to the 1 plus 2 because that's the row 1, column 2. And then how did we get 2, 1, 1, 1? Again, 1, 2 is cross out row 1, column 2. Oh, you cross out this one and this one. You have 2, 1, 1, 1, 2, 1, 1, 1 left over. Okay. Now, the last one is the same. You have a capital case A13, so here we have a sign -1 to the 1 plus 3. The index 1 plus 3. Here is the exponent. Now we should cross out row 1 because here is 1, 3, row 1, and column 3. You have a 2, 3, 1, 1, so 2, 3, 1, 1. Okay. Now here is 0, here is 0. 0 times anything is 0. Yeah, so it crashes this one. And the 0 also crashes this one. So actually, whatever here it is, we even don't need to figure it out. We don't need this number. Because we know here is 0, then it will crashes this one. Okay? That's why we make this place be 0. It's convenient. That's why we make this place be 0. It's convenient. Okay? So that's the reason to make some elements be 0. It makes sense in this case is that 2 places are 0. So we only need to consider the last one. Okay? So 1 times this cofactor. Now, -1 to the 1 plus 3, you know, that's 4. And -1 to the 4th is +1. So 1 times 1, the front is actually 1. Okay? But remember, there is an 8 outside. Those two are zeros. So it's actually 8 times 1, so you get 8 here. Okay, 8 times 1, you have 8. And then here 2, 3, 1, 1, you copy it. Again, then what do we have? 2 times 1 minus 1 times 3. So 2 minus 3 is -1. -1 times 8, you have -1. -8. Okay, right here. Okay, so that's the final answer for this one. And here we use the property, you can see, is we pour the constant out twice for column 1 and column 3. Then we see 1, 1. We like to make those places be 0 because we know if it's zeros, it crashes cofactors. Okay, we only need to consider the last one. Okay, so later on in this case, this is a very convenient way for us to find out the determinants of a matrix. Okay, so you only need to consider 2, 3, 1, 1 right here. That's the reason. All right, so we actually use the two properties right here. Constants, common factors can be out. Okay, here 2 out, here 4 out. And then 1 row, here is the last row, times a constant, here is times -1, add to the first row. It won't change the determinants, the value of the determinant. Okay, we use the two properties. We didn't really use the first property, exchange any 2 rows or any 2 columns. Okay, now let's look at this example. This example, 5, -4, 4, 1, 4, -1, 5, -4, 4. Okay, now right here, you know, we use first row. Actually, here is row 3 minus row 1. Previously, we used row 1 minus row 3 here. Won't change the value of the determinant. And then, you know, here we can use row 3 minus row 1. Since those two are the same, those two values are the same. 5 minus 5, you got 0. Negative 4 minus negative 4, you got 0. And 4 minus 4, see this 4 minus this 4, you got 0. Okay? And the last row is 0. The rest of them we didn't do anything. 5, negative 4, 5, negative 4, 5, negative 4. 1, 4, negative 1, 1, 4, negative 1. So if you got one row or one column is 0, then you know you get the determinant of the whole matrices is 0. Here is the details right here. Okay, you can expand this along what? Along row 3. Okay, you see that's the element A31, little case A31 times cofactor A31 plus little case 32, that's 0, right? Yeah, that's 0. Okay, and then times cofactor 32. And then again, A33 is this one. This element is also 0. This element is 0 times the corresponding cofactor. Okay, this is 0. 0 times anything is 0. Actually, I figured out the cofactors right here for you. You may look at that, the details. But you don't really need those negative 12, 9, 24 for the value of cofactors A31, A32, A33. The reason is you already got the elements at 0. 0 times anything is 0. 0 times negative 12 is 0. Even you don't find out negative 12, you know here is 0. 0 times anything is 0. And 0 times 9 is 0. 0 times 24 is 0. So you get the determinant is 0. If one row is 0, you get the whole determinant will be 0. That's the reason. Okay? And again, you don't need really here the values of cofactors. And here we use the property 3. Row 3 minus row 1. And there is row 1 minus row 3. The determinant won't change. That's the property. Okay? And then once we got 0, we know we don't really need that complicated calculation. One row is 0, whole determinant is 0. Okay? Please review these examples. I will see you next time.